intersecting lines. In this video, we're going to talk about how to find where vector lines intersect or vector equations intersect, or two lines intersect, all kind of the same way. It'll make sense. Everyone knows how to solve when two lines intersect, right? If I give you two lines, we know how to solve where they intersect. You can do just lots of methods: substitution, elimination, graphing. What about if I give you two vectors? If I give you lines in vector form like this, how do you find where they intersect? Well, actually kind of the same idea. What we do is we set them equal to each other. Because it's like anything else. When two lines intersect, you just set them equal to each other. That's how we're going to do here. So we're going to set line 1 equal to line 2. If I do that, I'm going to get this. Negative 2, 1 plus s 3, 2 is an equal line 2, which is 15 over 5 plus t times negative 4, 1. Okay, so you set them equal to each other, and then what do we do next is we separate them. So we're going to solve all the tops, all the x's, and all the y's. So I'm going to get negative 2 plus 3s equals 15 minus 4t. Right, that's the top line. I'm going to do the same thing with the bottom line, the y's. And remember, the s gets multiplied by both of you. Same thing with the t's. That's why you see them here. 1 plus 2s equals 5 plus t. So what do we end up with? Two equations and two unknowns. Just like a normal algebra problem. So we solve like a normal algebra problem. You try to solve for one of the variables, s or t, and try to find the other one. So in this case, let's get rid of the t's. So I'm going to simplify. You could actually simplify and make it like a more normal xy equation. I'm going to solve like this, so it's easy enough. Multiply the bottom row by 4. If I multiply the bottom row by 4, I'm going to get this. Let's see, I'm going to get 4 plus 8s equals 20 plus 4t. Top's going to be exactly the same. Negative 2 plus 3s equals 15 minus 4t. If I add these two rows up, my t's are going to cancel. I get 35 equals 11s plus 2. Let's solve for s. Subtract 2 from both sides. 11s equals 33. Divide by 11. S equals 3. Now, this is very important. You have to make sure with the answers. A lot of people want to stop here. That was not the question. Line 1. Use a method vectors to find where the two lines meet. So this is what we just found is when when line 1 hits line 2. It takes line 1 3 seconds, let's say, to hit line 2. If I went back and I found t, I'll be finding where how long it took line 2 to hit line 1. But that's not the question. It's where these two lines meet. So it's a point. So what you do here is once you find one, you're almost good. All I gotta do now is plug this guy back into its equation. Which one had s? S was line 1. So I'm plug it back into the line 1 equation to figure out what point they met at. So line 1 is negative 2, 1 plus, now I know it's 3 times 3 times 2. Simplify. And I get 7, 7. Or the point 7, 7, not the vector. So that's where these two things hit. They hit each other at 7, 7. And that's it. You don't have to find your t. Now if you want to verify, I'll find t. Right? So you know s is 3. If I'm going to go back here and find my t, it'll be 1 plus 2 times 3 equals 5 plus t. I get 7 equals 5 plus t. T equals 2. So I know t is 2. If I plug into the t equation right here, 15, 5 plus 2 times negative 4, 1. You get 15, 5 plus negative 8 and 2, which will get me 7, 7. Right, you're going to get the same answer. So very short, when you do these problems, make sure you know what the question is. Sometimes they want you to find t and s, and you have to go back and find both your variables. A lot of times, though, they want you to know where they meet. So once you find out where one thing hits, plug it into its equation to figure out where they met at. And then you'll be done. And that's it.